I am Josh Eckels at LabKey. I'll be talking second, but first, we've got Lindsay Pino, who's a postdoc at University of Pennsylvania and a co-founder at Talus Bioscience. And she's got extensive experience in the lab, actually doing system suitability. And then after she kind of gives that great background and motivation for why it's important and how to do it in practice, I'll follow up with some details on kind of the logistics of making that happen via Panorama and AutoQC and some other tools. So definitely encourage folks to go ahead and log your questions as we go through the Zoom Q&A. We're going to hold answering those until the end of the session. We've got a good chunk of time devoted then to work through those questions. But please go ahead and fire them off as you're thinking about them, and we will get to them a little bit later. So take it away, Lindsay.
Yeah, thanks, Josh. So yeah, if you've got questions, hit the question and answer at the bottom of the webinar screen, and we will be getting to those. So hopefully we will answer most of your questions throughout kind of these slides. This first part, we're gonna just kind of set up the concept of system suitability and quality control in these samples. Really quickly, my financial relationships, I'm currently employed at the University of Pennsylvania as a postdoc, but I'm also a co-founder and consultant at a biotech startup called Talus Bioscience. So just to start with a thought exercise, in quantitative mass spectrometry proteomics, we use chromatograms to compare different peptides, different proteins between two samples. So if I see a chromatogram on the left from one sample, and I compare it to the chromatogram on the right from a second sample, I see that the chromatogram on the right is 3 times more intense, 3 times larger area, 3 times more abundant than the sample on the right for this peptide. So when I go to analyze my data, what I'd like to say is that these two samples are differentially abundant. However, could there be another reason we have different sized peaks from these two samples? What if it's the exact same sample run 2 times in a row? Could you get a different quantity from the same sample? I think a lot of us in here, just looking at the names popping up in the attendees, yes, we absolutely know that there are many reasons you might get a different quantity, even if you run the exact same sample multiple times. So the 3 main points for you to take home from this part of our seminar today is first, to compare when you would use quality control, when you would use system suitability. They're not the same thing. Second, learning how to set up a Skyline document for whatever you're using for quality control or system suitability. We're going to set up this Skyline document so that we can plug it into a little tool called AutoQC, which Josh is going to tell you about more in the second half. And then finally, if we have some time, I'm going to show you what some of these kind of practical LCMS troubleshooting figures would look like with some real world examples. Okay, so if we imagine on a horizontal axis, different quantities of protein, with high protein on the right-hand side, low amount of protein on the left-hand side, what we would expect is that for some given quantity of protein, of peptide, of analyte, really anything, we would expect our mass spectrometry signal to give some value that can be related to that quantity. So if I decrease the amount of quantity of analyte in my sample, and I measured it again on a mass spectrometer, I would expect that the signal should correspondingly decrease with a decrease in the quantity. But like I said, mass spectrometry is not inherently quantitative, and there's a lot of reasons you might see a change in signal that is not due to a change in quantity. So the first one would be an actual true change in quantity. I have 2 different samples and they actually have a biological real change in quantity. However, what if I have the same sample prepared by 2 different operators? It is very likely that the operator, the scientist preparing the samples, is going to introduce small variations to the protocol and result in a different quantity of analyte being extracted and prepared from the sample. Or you could have the exact same sample and then go run it on 2 different instruments. I know in every lab that I've been in so far, we have duplicates of the same instrument, 2 Q-exactive HFs, 2 fusion mass spectrometers, and there is always a good one and a bad one. And for whatever reason, the good one just seems to perform better than the bad one, even though they're supposed to be the exact same hardware. So if I ran the same sample on the good instrument versus the bad instrument, I would get a different quantity. It could even be the exact same instrument, right? Over time, the mass spectrometer will become dirty and need to be cleaned, and that will cause the perceived quantity, the measured signal, to decrease over time. So for all of these reasons, we might have 2 different chromatograms that look like they are threefold different, but actually it's not due to the sample, the true biological difference in the analyte. It's actually due to the sample processing, or it's due to the system itself, the LCMS system itself. So one of those reasons is the instrument, the platform performance, the LCMS itself. So this gets into the concept of system suitability versus quality control. And this is something Sue Abatiello really hammered into my mind. They are not the same. The concept is the same, but a QC, a quality control, is really for the method. So this is thinking about the sample preparation itself. A lot of times, if you're in mass spectrometry proteomics, I see a lot of you I recognize in the mass spec proteomics community. A lot of times we use a isotopically enriched standard, so a heavy standard, a stable isotope labeled standard, where one standard is a light distribution, so kind of endogenous isotopes in the sample. And then you might have a heavy enriched, heavy isotope enriched version of that sample, so that you can spike it into your sample processing protocol at different points with a known quantity in the heavy and a known quantity in the light. And if you compare the two, you can see where losses are occurring. So a QC is typically method specific. What you would use to QC a proteomics workflow is very different from what you would QC for a small molecule workflow. And both of these are different from a system suitability. So QC is the method itself, the actual physical samples. System suitability is for the system, the LCMS. So this is going to address questions like, is my instrument performing the way I think it should? Do I need to troubleshoot something? Is my retention times, are they reproducible? Is there something wrong with my column? Is there something wrong with the solvent delivery on my LC? My mass spectrometer, are the peak areas going down over time? That might indicate I need to clean it. Is the mass accuracy, the ppm, starting to drift? I need to mass calibrate my instrument. So similar concept, trying to just get a benchmark ground truth known of your sample, so that when you go to assess the unknown, the biology, you're actually able to measure what's coming truly from the hypothesis you're trying to test. So just a quick overview of the mass spectrometry proteomics workflow to get into more detail about these concepts I just mentioned. So we start with some sample. It could be anything, right? Here I've got a whole bunch of human samples, but I know there's those of you out there doing crazy things in ants and water bears and whatever you're doing. The goal of these workflows is to start with a sample and to end with a mass spectrum, the MSMS, or the chromatogram. I think about chromatograms mostly more than mass spectra, but you might be thinking more about just the MS2 and not the chromatogram. So we take our sample, we extract the protein. We typically digest for a bottom-up proteomics workflow. Now we have peptides ready for the mass spectrometer. We separate those peptides by liquid chromatography, and then pass those peptides through the instrument through stages of precursor selection. We fragment, we collide all of those precursors to generate fragments, and then we detect and measure those fragments and record that data as mass spectrum, which we can then stack to make a chromatogram. So this is actually a really long workflow compared to a lot of other protocols in biology and biomedical research, this is a pretty intensive workflow, and we don't have the luxury that genomics workflows have of just amplifying our analyte. We can't just amplify the protein to get more of it. So each step of these workflows, we have to be very careful, very analytical about what might be going wrong so that we can get back to our original hypothesis. So let's focus on the top half first. So this top half is quality control, right? So this is all generating the samples. So we're talking about quality control up here. In the first step, a lot of things that can go wrong. If you're working in tissue, you need to homogenize your tissue. Cellular lysis, if you're doing subcellular fractionation, you're isolating the nucleus or you're isolating the mitochondria. This is all stuff that has to happen before you can even extract your protein. After you extract your protein, there might be a whole nother set of manipulations that you're performing. You might be doing fractionation. You might do a PTM enrichment to pull out, for example, phosphoproteins or ubiquitinated proteins. You might perform an immunoprecipitation. Maybe you did one of those cool proximity labeling assays and you're doing a biotin streptavidin enrichment from the sample. Maybe you have just a co-IP experiment, so you have an antibody for the protein you're interested in. So a whole nother round of sample manipulations at the protein level. And then we do the digestion. Doesn't matter what kind of digest enzyme you're using, there's a whole bunch of parameters here that can go wrong. So the digest efficiency might be affected by how long you're doing the digest, how much protein to enzyme ratio you're using, what temperature you're working at. A lot of the in solution protocols call for 37 degrees. A lot of these cool SP3 protocols call for 47 degrees. What temperature, how long, how much enzyme are you adding? And then finally, once you get the peptides for mass spectrometry, there's typically one more round, right? So you might, at minimum, do a sample desalting, a sample cleanup step to remove any detergent, remove any salt that might be remaining in your sample that we don't want to put into the LCMS. You might perform isobar labeling if you're doing TMT or iTrack. You might do another round of enrichment. For example, phospho, you might be doing another round of phospho peptide enrichment. So there's a whole lot of things here that can be going wrong. So some of the common QC approaches try to isolate individual parts of this protocol so that we can answer one question about what might go wrong. So for digestion might go wrong. One common QC approach is to have an internal protein standard. So internal standard, you put it inside the sample. You add the protein standard before you do the digest, then perform the digest, your endogenous biological proteins are being chewed up, and also your internal protein standard is being chewed up. Now, once you have peptides for the mass spectrometer, you spike in an equimolar mix of internal peptide standards that represent peptides from the internal protein standard. So now when you go to analyze the data, you would expect if the digestion went 100% perfectly, you should have an equal number of internal protein standard peptides as the internal peptide standard. The peptide and protein should match if it went 100% perfectly. If it didn't go perfectly, now you have a measure of exactly how bad the digestion efficiency was. Another QC approach is at the enrichment step. So in phosphopeptide work, phosphoproteomics work, a lot of times these assays will include an internal phosphopeptide standard that is labeled two different ways. So maybe a medium isotope label and a heavy isotope label. So this is just adding different amounts of 13 carbon and 15 nitrogen that are present at a higher abundance than naturally occurring, 12 and 14. These internal peptide standards now, when you spike them in after you do your enrichment, you can tell if the enrichment went 100% perfectly, the measurement, the quantity of these two standards should be equal. And if they are not equal, now you have a measure of just how poorly the enrichment went. Then there's this whole other idea, instead of isolating each one of these individual steps to get a process level look, having an external reference standard. So this is a completely separate sample that is similar in complexity to the samples you're doing. So if I'm doing, a cardiac tissue project, I would take some big pot of cardiac tissue, either small amounts collected, aliquoted off of each one of my experimental tissues, or looking into repositories like NIST, National Institute for Standards. They might have different types of external reference standards that they have extremely thoroughly QC'd and validated. You purchase those, you prepare, your 10 samples, and you add this one extra external reference standard. Now that external reference is experiencing the protein extraction, the enzyme digestion, the peptides for mass spectrometry. It's capturing all of those different steps in the process. So now you can compare just an overview of the entire protocol to see how did this external reference standard compare to previous batches that I've prepared. So I kind of mentioned this idea of internal and external standards, but just to clarify, if this is new to you, external standards, there's a lot of options for external standards. Internal standards means you put it in the sample with your actual biological proteins. Synthetic peptides, I think, are the most popular, which you order them from, Cambridge Isotope or Thermo or whatever. You send them the sequence, they send you back a synthetic peptide that they synthesized. And typically this has a heavy isotope labeled amino acid in it. So that's the most popular, but that doesn't capture digestion kinetics. So some researchers have been working on the idea of winged synthetic peptides. So a winged synthetic peptide would have a couple amino acids on either side. So when you digest it, now you're getting a measure of the digestion. And then there's these synthetic or purified proteins that I mentioned. When you go to analyze the data, now you have co-eluting in the same sample a light, your biological, and your heavy, so you can compare the peak area. So if I were doing some sort of enrichment in this sample, obviously this enrichment did not go 100%. I'm not getting exactly the same amount that I put in. Then the idea with external standards, you would prepare your sample like usual, and you would measure your biological sample as usual. Then you would prepare a second external sample of reference material, and then you would compare those two measurements in the two different samples. So here again, just showing you the exact same concept where clearly I'm not getting exactly the same signal that I would have expected if my process went 100% perfectly. So there's pros and cons to each of these, and you don't have to use one exclusive to the other. You could use both in your protocols as quality control. You can have internal standards and an external standard. So it's kind of like all of the QC approaches. Just as like a quick summary, for digest, typically people use protein standards, but you could also use a winged peptide. For enrichment or cleanups at the peptide level, usually stable isotope paired peptides are used. If you want to look at the entire process, finding a good global external reference. So I wanted to add this in here because I do see some questions doing small molecule. For small molecule work, there's a really great paper, St. John Williams et al. 2017, link at the bottom, that really goes into detail about how they implemented a lot of these QC ideas into every one of the 96 well plate batches of samples that they did. This is a great example of these practices being put into use in a large scale study. So we just talked about quality control, the stuff on the top, but now let's talk a little bit about the instrument variability. So this is really the place I see AutoQC and Panorama being used most often. That is to say, you can also use these concepts for what I just talked about with quality control. So you have the peptides. You separate them by liquid chromatography. We process them in the mass spectrometer, select, collide, fragment, measure fragments. We get the mass spectra or the chromatogram. There are a lot of components here that can go wrong, even if our samples were prepared perfectly. So there might be issues with chromatography, which would affect the retention time. Your mass spectrometer might need to be calibrated. The mass accuracy would be a metric for that. You might have issues with fragmentation. I just 2 weeks ago had an issue where I was looking at my data and the precursor fragment area ratio just didn't look right. And it turns out we go and check the tank and all of the nitrogen's gone. So we weren't fragmenting any of the precursors. And then finally, the peak area or the peak shape. This might indicate that if the peak shape doesn't look good, your chromatography has an issue, either the column or the solvents. And then for the peak area, if the peak area is continually decreasing, that might indicate that your mass spectrometer is getting dirty and we need to clean either the front end or hopefully not deeper into the optics. So typically these system suitability samples are an external standard, so not something you spike into your sample. It can be internal. Typically they're external standards. And when you go to queue up your experiment on the mass spectrometer, you would run maybe 3 of these system suitability standards just to see if your values are reproducible. Is your retention time stable? Is your mass accuracy stable? Is everything stable before you run your precious biological samples? Then interspersed in between your biological samples, you would run one of these system suitabilities. So what you choose as a system suitability sample can be entirely up to you. These are just some guidelines. Basically, examples that I typically see people using: a cell lysate that they digested in bulk. This can be yeast or HeLa is the most common one I see, is using a HeLa digest. The other most common thing I see is using synthetic peptide standards, typically some sort of retention time calibration kit purchased from a vendor. So using like the Pierce retention time calibrant mix, using the Biognosis IRT retention time calibration mix, purchasing those and then spiking them into a somewhat complex background. So when we measure all of these system suitability samples, kind of the next thing that we want to do is actually evaluate them, right? So I see a lot of people use Excalibur and like templates in Excalibur to do this, but I like using Skyline. It's a little bit easier for me than Excalibur. I'm not quite the Excalibur wizard that I know some of you are, just looking at the participant list. To set up this Skyline document, I'm just going to walk you through it if this is your first time looking at Skyline. So over on the left, this is a list of all of the peptides that you're measuring in your system suitability. In this particular system suitability, it's using the Pierce retention time calibrant mix spiked into bovine serum albumin digest. So these can be whatever peptides, whatever small molecules you're using for your system suitability. You just type them into Skyline. Then you import each one of your data files. So each one of these chromatograms on the bottom is a separate system suitability sample acquisition. For me, I like to run these about every 12 hours, about 2 per day, but maybe your system is rock solid and you can trust it to go for a day or 2. Then the top 2 windows up here in Skyline are showing a retention time and a peak area comparison across all of these samples. So each point on the x-axis is another sample, and then on the y-axis for retention time is giving the values in minutes, and then in peak area on the right, the vertical axis is showing you the total peak area, MS2 peak area for those analytes that are in the target window on the left. So really, in this document, I'd be looking at retention time, I'd be looking at peak areas, and ideally, neither of these should change, right? In an ideal world, my system is rock solid, so analyzing the same sample multiple times should give me the same values. And this is just to say, this is something you can do with small molecule as well. So this is an example of the exact same style document, but instead using standards for small molecule from a vendor Biocrates. So this can be really powerful. You wouldn't expect retention time, you wouldn't expect peak area to change over time, but this is that longitudinal study that I told you about before. So this is over 296 well plates worth of samples. So that's over 15,000 samples. And you can kind of see between 2016 and 2018, the retention time is just totally rock solid. And then, something weird happened in the middle here. So that's a point that you could stop running your precious samples and go back to your system and check what's going on. Is this like a column issue? Is this is my liquid chromatography system not working correctly? And then you can see the same in the peak area on the right. There's a point just down at the little past the midway mark where the peak areas all went to 0. Is this an issue with the system that indicates I need to stop everything and go clean my system or troubleshoot my system? Or can it be something more innocent? So typically, the way I used to do this would be I would stick the Skyline document on my instrument computer, and as files were being acquired, I would one by one go file, import results, and then manually go through and curate it. Then every instrument had to have the Skyline document there, and everybody had to be accessing it and using it for me to get a longitudinal view. Obviously, the people at LabKey were like, this is dumb. Why can't this be automated? So that's exactly what they did. And this is exactly what you're going to be hearing about more next. So that's using this small program called AutoQC, which is an executable that lives on the instrument computer. In the Q&A, if you don't have internet access and you can't do that on your instrument computer itself, I can tell you about some hacks that one of the super bright grad students in my UPenn lab put together so that we could be using AutoQC. So I think Josh is going to be telling you a little bit more about that, but I wanted to just quickly point you to a quick tutorial that sets up a Skyline document for whatever you're using for your QC or your system suitability. So I have this link in here. I'll stop sharing real quick and just bring it up. So this document, I'll make sure you get a link available. And I'm just going to launch a blank document of Skyline and share that with you. So in this blank Skyline document, and all of this is really fully detailed in the Google document that I'll make sure you all get. The first step, just a totally blank Skyline document. I'll make sure I have my default settings. So in this document, first we'll set up the peptide settings. So under settings, peptide settings, I'll just set up the digestion filter, all default, the prediction filter. This doesn't matter, we can leave this default. The filter, we'll change this just because of the way that I've set up this document. This FASTA file we're going to import. We're going to change the minimum length, the maximum length, and we're not going to exclude any of the N-terminal amino acids. Go to modifications. That all looks good. I'll make sure for these particular, I'm using in this example, the Pierce retention time calibration mix. So those are heavy isotope labeled. Isotope modifications are heavy lysine, heavy arginine. So those are good. I would go File, Import, FASTA. And now in this tutorial document folder, I have the link to give you. In this tutorial folder, I have a prtc.fasta. This is just, I took all of the Pierce retention time calibration peptides and I just pasted them all together into a pseudo protein so that Skyline can digest it. And it'll give us all of the peptides in Pierce. If you're doing any other protein, you would just do the exact same thing. You would do file, import, FASTA for BSA and have all of the BSA peptides come in. When you want to set this up on your instrument computer, you just do File, Export, Transition List or Isolation List. Transition List if you're on a triple quad, Isolation List if you're doing a PRM. Skyline has all of the options for you for whatever instrument that you're on to export these peptides, and it will give you all of the isolation list master charge for you to import directly in your instrument editor on your instrument computer. So I have in that document, I also have instructions for setting up an instrument method. It is just for thermo. That's all I have access to right now. But if you have any questions in that tutorial, let me know. And I think I'm at my 30-minute mark, so I will pass it over to Josh. But yeah, we'll have more questions. I'll answer what questions I can in the chat and make sure that you have the link to the tutorial.
All right, thanks, Lindsay. And yeah, thanks everyone who's logging questions. I've been trying to answer a few of them here on the fly, but there'll be plenty of time to get to others later. And some I may touch on slightly during my section, and others we'll look back with Lindsay specifically. So please keep them coming. Thanks. And kind of in that spirit of making this collaborative, despite being distributed and virtual here, I'm going to try using the Zoom poll feature. Try and get a sense of kind of who's on the session and kind of what your background is. So if you wouldn't mind, I've got three questions I'll sprinkle throughout my section, and I'd love to kind of understand more about who you are and make this as relevant as we can. So I see answers pouring in. Thanks, everybody. And I'll get to that in a second. So real quick background about LabKey. So we are a company that does data management solutions for life science. So we have worked for 16 plus years on something called LabKey Server, which started out as a proteomics database search pipeline. So we've got a long history working in the mass spec realm. Spun out of a proteomics lab at Fred Hutch in Seattle. And since then, we've diversified and worked on a lot of different things. Obviously, the reason I'm here today on this session is for our targeted mass spectrometry repository called Panorama. But we've also been working on some other very related things around biotherapeutic development and sample management that I wanted to highlight very briefly here, because we see the potential for a lot of great connections with Panorama going forward. So Biologics is our product that is really purpose-built for full biological entity assay and sample tracking, to take that full workflow of developing, characterizing, and refining those biologic therapeutics through the whole pipeline, having an electronic lab notebook, an ELN, kind of annotating and capturing that data, and really easing the workflow and data management side. And obviously, we've been thinking about how we get mass spec analyses fed in, and Panorama's been adding new support for multi-attribute method. And so I wanted to make sure folks knew about that. Then the other side is work we're doing on Sample Manager to do end-to-end sample tracking. So that's the full kind of chain of custody tracking. It's really a sample-centric approach to freezer management, being able to see the history of a sample and where it's been in storage and things like that. And as well, having a lot of those workflow tools and being able to pull in assay data around that, including being able to link to mass spec data stored in Panorama. So that brings us to the main topic here on Panorama. It is our data repository for targeted mass spec analyses. We've got a number of, I think of them as kind of different usage modes. And the first one here, system suitability and QC, is obviously the most relevant for today's discussion. But we also have these different modes to build and then And then export chromatogram libraries. If you're not familiar with those, think of them as kind of the chromatogram equivalent to a spectral library that you may be more familiar with. Just being a general data archive, being able to search for a particular protein or peptide or small molecule across all the data that you've accumulated. So instead of having, say, thousands of files on a network file share with some perhaps convoluted directory structure, or maybe you've got a lot of data files that are on a postdoc's laptop that really could benefit from being more centralized, a little more durable to be reused in the lab after they leave. And then an area that the McCoss Lab has really been working hard on, Vidisha Sharma in particular has been doing great work on something called Panorama Public, which is using Panorama as a way to distribute the supporting data for publication. This has both the Skyline document as well as the raw files to kind of meet the full journal requirements for that supporting data. Panorama is really directly tied and integrated with Skyline. There are menu options and things like that in Skyline to be able to push data directly into Panorama. And we've been at this for quite a while, coming up on 10 years. It's really been a fun project working closely with Brendan McLean and the rest of the Skyline team in the McCoss Lab and the rest of the LabKey team to bring this out. So looking at the poll results, thanks everyone for logging. It looks like most folks have worked with Skyline. About 79% of attendees, 17% said they had worked with Panorama, and 11% on AutoQC, leaving us with 27% that are getting their first exposure to this. So thanks, that helps, and it's great. I hope today you'll leave with some follow-up steps where you can say, great, for system suitability, now I know about this new tool suite, and I can pretty quickly and easily jump into that to reduce some of that drudgery from everyday life in the lab. So Lindsay gave a great overview of system suitability in general. I will caution you that I am a little bit less rigorous in my separation between system suitability and QC, and you'll see that reflected in some of the Panorama user interface as well. I think we're thinking about getting a little more in sync with Sue's definitions, but just keep that in mind as I show screenshots and so forth here. But really, we're looking to monitor performance of the instrument and the whole system over time and capture that whole history. And if we can, some additional context so that if we see a particular problem recur, we can much more quickly diagnose and address it without having to reinvent the whole process. Lindsay gave a nice summary of different ways that you can spike in to an existing sample, that you can run samples independently. And I know different groups have different cadences on which they run their controls, whether that's every 12 hours, like Lindsay mentioned, whether it's every 10 runs, whether it's the first run of the day, just depending on what their workflow looks like and how reliable their results are. One of the things we really pride ourselves working with the Skyline team is that we're agnostic for the instrument type or vendor. The Skyline team works really hard with all the major mass spec vendors to keep supporting their new instruments and their new file formats, and we're definitely benefiting from that. And then I also wanted to kind of call out all of what we've done on the Panorama side has really been inspired by the tool that was a Skyline external tool called SPROCOP, Statistical Process Control and Proteomics. And in particular, thanks to Michael Berriman, who I'm sad to say passed away earlier this year, for, really want to thank him and his whole team in North Carolina State for kind of paving a path on this and being great collaborators in helping us make it more automated and roll it out to an even wider audience. So the overall workflow that we're aiming for here is as automated as we can make it, and also as iterative as we can make it. So we've got our instrument down here in the orange in the lower left, acquiring data. At least initially, that goes through Skyline, and Lindsay gave you a little flavor of what that looks like to set up your document and configure what your targets that you're monitoring, and then pulling in the raw data files to analyze and then upload that into Panorama, where we can see that in a web interface. We can always download that back to Skyline. We can get it in other formats. We can just give users or collaborators direct links to the data in Panorama. And then what we want ultimately to kind of make this faster and more automated is to kind of have this bypass lane here. So instead of having someone needing to import that new sample that was just acquired into your Skyline file, having AutoQC that Lindsay talked about, that automated program that's just watching for those files to be acquired, automatically analyzing them based on the targets that you've set up in your Skyline document, importing into Panorama, sending out email notifications, and letting you know everything's fine or everything's not fine. You need to stop the instrument before wasting any of your precious experimental samples when your results are going to be suboptimal. So the basic workflow, start to finish here, is to choose your sample. Lindsay gave good pointers on that. I know there's some questions that we'll get to in the Q&A section, and create that Skyline document. I've got a quick tutorial on that. Acquire your data on the instrument, get that into your Skyline file, import that into Panorama, view your data, repeat every day, every 10 samples, whatever your frequency is, so that you can be assured that everything is working the way it should be, and your results are comparable to other data that you've already acquired and are analyzing against. So in Panorama, we monitor all of this in what we call a quality control folder. So here's a case where perhaps it should be more explicitly system suitability, or at least include both in our name. But the scoping that we're aiming for is one folder per instrument, because each instrument is going to have its own particular profile. You know, you've got the good one and the bad one, and if you have those mixed together, maybe they're not aligned. You're seeing, you know, peak areas that are off by 10% across them, and so that's going to introduce a whole new level of variability. So when we're monitoring an individual instrument, we want to have it in isolation. Of course, we may want to be able to compare across instruments later to really calibrate everything across all of our data sets. But for system suitability, focuses on one instrument at a time. And then have a user interface within Panorama that's explicitly devoted to this approach. So these longitudinal plots, similar to what Lindsay showed, you could do in Skyline, except with a relational database behind the scenes, being able to have an even longer time period that we can visualize and track and analyze. And that we can go across many different Skyline files, so that you don't necessarily have to have the thousands of data points or thousands of different samples in a single Skyline file. You can be uploading them incrementally and then having access to that full data, both through the web interface and through API and other tools if you want to have downstream analysis on it. So the starting point that I always recommend for people looking at this is something that we call the Levi-Jennings plots in Panorama QC folders for system suitability. So the easiest place to start is to just look at one molecule at a time, whether that's a peptide or a small molecule. We were working equally well with either side, and look at its performance over time. So I'll talk more about the different metrics that we've got available to us, but kind of start simple, just look at retention time. And so in an ideal world, this is a horizontal line, slope 0, and everything for a given molecule or peptide is completely consistent. The real world, of course, does not agree with that wonderful theory, and we've got some noise and variability, And what we're looking to do is have everything within kind of a normal predictable range. And so the system will automatically look at all of our data points that we've acquired and calculate the mean and standard deviation. And the definition of outliers here is anything that is more than 3 standard deviations from that mean. And I'll talk more about other ways of looking at this data downstream once we have it dialed in here and running reliably with these plots to help expose other types of variability that are important. But this is a good place to start. So we can look at either individual peptides or molecules one at a time, like this top plot, or we can say, well, let's look at all of them that I'm tracking. And I know there's some questions, and we'll get to this in the Q&A on how many to track and how to select them. In general, for system suitability purposes, we recommend having a relatively small number of molecules that we're monitoring, a dozen, a couple dozen, something like that. Stable performers. We don't want to have variability because one peptide degrades more quickly than the others. We just want to know, is the instrumentation itself performing as it should be. And let me launch my second poll. Share a result from the first one and go to my second poll. So I'm curious what types of metrics folks are typically monitoring. This is a subset in the poll of the full list that Panorama's got, and that we're continuing to grow this. But I'm definitely curious what's people's kind of go-to metric for doing their system suitability assessments. So in Panorama, we've got a significant and growing number of metrics that we can incorporate. I'll talk a little bit more about being able to customize those later. And the majority of them are per molecule. So retention time, of course, is scoped to a peptide. But we've got a handful that are really scoped to the sample. So a good example is the total ion chromatogram area, the tick area here, which is just what's the total signal that the instrument acquired across that entire sample. And that can help us reduce some of the variability maybe on a single molecule and kind of have a quick at a glance to the full sample and full signal that we're getting. And we're continuing to add new metrics based on feedback from users. We'd love to hear things that you're using and that have been helpful, and figure out how we can make them general and roll them out more widely. So I'm going to end the poll here and share those results. And it looks like peak area is kind of the dominant thing that people are monitoring, with retention time having a pretty significant focus as well. And then, so now we've got kind of our baseline, our kind of default set of analysis results for system suitability, and we want to start refining that. So one of the things that we may want to do is kind of throw out problematic data points. So we've got one sample where something just didn't go right. Maybe maybe you ran out of sample. Your auto sampler was effectively empty, and so you've got very little signal, and you want to exclude that so it's not shifting your mean, your standard deviation, or otherwise impacting your outlier calculations. So within Panorama, we can just go ahead and click on one of these data points. Let me see, this one's got a clear shift in retention time by a couple of minutes. And we could say, let's go ahead and exclude that either for this single metric. So just for retention time, let's go ahead and ignore that. Or there's something wrong with that whole sample. Let's exclude it altogether from our calculations and outliers. And the nice thing about this, instead of just deleting it, we keep it behind the scenes, and we can optionally pull it back in to see, maybe we have another case that maybe it was the same problem. And so we haven't completely deleted it, but in general, we get it out of the way. It's not impacting our outlier calculations, and is not kind of skewing our plots and otherwise messing things up. So then getting a little more complicated and a little more refined. Like I said, by default, we look at all the data points that are imported into that folder for that instrument to establish the normal range, kind of the training set for what that assay should be doing. But we can customize that and say, no, I want to not pull in everything because maybe I've got an ongoing problem with calibration and the instrument's performing well right now. I want to kind of lock in what that performance is at the moment so that as maybe my peak areas drift down, they don't start pulling my mean down as well. So we can look at our data, find a time period of stable performance, and then kind of say, use these data points, please. Of course, we want to have a significant number of points here. We don't want to do it off of 2 or 3 points. Our standard deviation will be pretty much nonsensical if we do. But then we can use that training range to score and evaluate outliers going forward. So here's an example. If I've got my default range that's including all of my data points, I can go and click Create Guide Set, and then I can drag to include whatever set of samples I want to have as that training range. And then when I do that, we can see my mean and standard deviation shift significantly. In fact, here, the mean was somewhere around 14.7. And so it shifted up to 15 plus minutes. And we can see we've got kind of a period of a pretty stable performance here, a little upward trend. But then something significant happened and everything shifted a little bit earlier in that acquisition. But this gray shaded area here, that's telling us that's our guide set. That's the range that's being looked at to calculate what the normal is. And then everything else going forward is looking back at that. I could go ahead and create another guide set. Let's say I swapped in the column and everything shifts by some amount. I could say, okay, starting here, use this as the new normal range going forward. But generally, folks are looking to have a guide set kind of established once, and then calibrate against that and look to keep performance in line. So then looking at our data and trying to find out what are the sources of variability, what are maybe some of the other metrics that I should be looking at a little more closely in addition to, say, the peak area and the retention time. So these Pareto plots are a great way of doing that. So what we have is across all of our samples that are in our folder, we look at all of the different outliers, those that are greater than 3 standard deviations from the mean, and across the different metric types, which ones give us the most outliers. So here we can see mass accuracy is kind of the most problematic or the most variable of our metrics that we're looking at, followed by retention time and transition precursor area ratio, peak area, and so forth. So this gives us kind of at a glance a way to see what are those biggest problem areas. Where should I be focusing on troubleshooting? Where do I need to maybe be the most cautious in terms of interpreting my experimental results because we've got more noise and more drift or any other sorts of trends. And then going beyond that, kind of once we've got our system pretty well dialed in, we're comfortable with its performance using these Levi-Jennings plots, we can look at other types of analyses that I won't go into great detail here, but they help us analyze other kinds of trends that may signal there's a data quality problem. So these moving range and cumulative sum plots, or QSUM plots, are really great at helping us detect increased variability. So let's say we've kind of got more up and down, even though our mean may be about the same. The moving range can help detect that kind of shift. And these cumulative sums are great for kind of looking at these longer term trends. Maybe we're drifting upwards or downwards. We're still within our 3 standard deviations, but there's a clear trajectory and maybe that signals, hey, once we're approaching kind of an outlier threshold, that's a great time to perform calibration. Maybe it's a great time to call out a service technician to look at the instrument and make sure it gets back to its normal performance. And on that point, we have some Panorama users who, the first thing they do as soon as the service tech says, okay, your instrument's all set, I'm done, is they say, nope, don't leave. Let's run a couple samples through this system suitability analysis. And then only when they get back to the normal range are they allowed to take off and sign off on the work being performed. Annotating the data. So this is something to help keep track of what happened. Why did things shift? You can do it ahead of time. If you're making a change to the instrument, you can kind of log that to say, right, we did a calibration, or we replaced the column, or did anything else. Maybe we swapped in a new lot number for our QC standard. But this is a way to just kind of track that. Maybe you do it ahead of time, maybe you do it after the fact, after you've noticed there's a problem, and have that kind of shown in these plots. So again, we can look in the future and hopefully save time if we see a similar trend that we need to troubleshoot next time. We got lots of options, lots of different kind of variations on visualizing this data. We can change our Y scale. We can group by day, zoom by dates, hide, show, exclusions. So doing something like, instead of applying the raw values, doing the percent of mean can be a great way to look at things where across different peptides or molecules, we've got a pretty significant range in peak area, of course, is a great example where we may have a significant range of abundance by design, because we want to have stable performance for both high and low abundance peptides. But this is a way to kind of normalize those on the plot to figure out how the whole system is performing. We see there's a clear downward trend on peak areas. That's a lot clearer when we don't have that huge difference in dynamic range. And down here, by grouping by day, we can see something clearly happened midday on August 21st here. We have a set of points where retention time is kind of in the same range as the prior history, and then a real shift down, and that maybe it was because we replaced the column on that day. So kind of showing how these different groupings and the annotations can kind of overlay to help us figure out what happened and when. And then we want to make this as automated as possible, right? No one really wants to spend all their time doing system suitability. You want to be analyzing your actual data, but you want to have confidence that your results are reliable. And so AutoQC, like Lindsay said, really kind of takes that drudgery out of the workflow. So it's a standalone program. So it's separate from Skyline itself. It's a separate thing to install. But you put it typically on the instrument computer. Sometimes the instrument computer is locked down and you need to put it somewhere else that has access to the files. It sits there running in the background, diligently waiting for new samples to show up, notices that file, analyzes them using your Skyline document via Skyline runner. So you don't need to open Skyline. There's no user interface needed, no user intervention required at all. And then it can automatically upload it to Panorama. And so really, this is what AutoQC looks like. This is what that tutorial that Lindsay mentioned, and we'll include links in our follow-up notes on how to find that. But you point it at a Skyline document that you've created to monitor the molecules of interest. You point it at the spot where the raw files will be acquired to. And then we point it at a Panorama server. So that can be Panorama Web. That's the server that the Cost Lab generously hosts and gives free projects to everybody. Or it could be your own local installation of LabKey and Panorama. And then you start that profile. and it runs in the background, and you can set it so that when the instrument computer restarts, AutoQC pops up again, and it's logging your data and automating your whole workflow. You can have multiple configurations. If you've got maybe 2 different projects, or you've got access to data from multiple instruments that you want to have a centralized AutoQC installation that's monitoring all of them. It's easy to set it up with kind of different profiles or configurations with different target folders in Panorama and different Skyline documents that it's pulling from. And then the last poll question will be number 3. Curious kind of how many instruments people are potentially monitoring for system suitability. So one of the things kind of as we built out capabilities here in Panorama is that, great, it was helpful to be able to see an individual instrument, but then what about the rest of the instruments in my lab? I don't want to drill in and look at them individually. So we've got these summary dashboards where we can see what are the most recently acquired files and how many outliers do they have. And this one looks like they've got some significant outliers, probably requires at least a little interpretation, if not intervention. And we can also see, is AutoQC still running? Is it still checking in with Panorama? Because even if it doesn't have a new file to upload to Panorama, it'll still tell Panorama, hey, I'm alive, I'm looking for files, nothing to report yet. And so this little green check mark says this one is actively running. The red says, ooh, AutoQC is offline, maybe something went wrong with the Windows update or something like that. And we want to loop back and understand why isn't it started and get it running again. So we've got share the results. So yeah, it looks like pretty good range. Some folks, about a quarter of people have one instrument in their lab, and then kind of evenly distributed across kind of 2, 3, and more. So especially for groups that have multiple instruments, these kinds of dashboards I think can be really helpful to understand kind of the lab at a glance without having to look at each one. And kind of wrapping up here, we've got some premium features that are available to you if you're on Panorama Web, and we can augment a local installation of Panorama if you're doing your own in-house server via these premium features. To refine the metrics, so as we have a growing set of these, not all of them are going to be interesting or relevant to everyone. We try and automatically hide the ones that aren't as interesting or where we don't have the data, so they're not kind of in the way. But you can explicitly say, I got a lot of noise from full width at half maximum for the peak size. I'm going to disable that instead of having it constantly be a source of outliers. I can add my own metrics. If you've got something specific you want to monitor that isn't one of the built-in ones via a little SQL query that you configure within Panorama. And then you can also subscribe to email notifications. So as soon as AutoQC uploads that new data, you can get an email from Panorama. If there are problems or if everything's good, you can kind of set what your threshold is to know when you want to intervene. And so that's kind of on a per user basis, on a per folder basis. So you can say, I care about these 2 instruments. I'll let other people care about those other 3 instruments. And just let me know when I've got a trend of imports that have at least 3 outliers, or let me know every time any AutoQC import is complete. What's new? So if you've already been familiar with AutoQC and Panorama, hopefully some of these things will make your lives better. So we keep on adding new metrics in Panorama. Pressure traces from the instrument, kind of a new chromatogram that we're monitoring. So tell me the time at which the system gets up to a given pressure to know that I've got a reliable signal. That's going to be in our next version, which is coming out just about 2 weeks from now. The total line chromatogram that I mentioned earlier, that's a new one from the last couple of releases. We worked with Thermo Fisher on getting support for some of their Pierce isotopolog peptide kits. These are the 7x5 kits that let you do a full calibration curve in a single sample to monitor LOD and LOQ as part of a metric. That was a pretty cool project. We're looking to add ones based on IRT metrics, so like a correlation coefficient or a slope or something like that in our next release. We've been working to automatically link your experimental data with your system suitability data because we know what instrument it came from, including the serial number. If Skyline was able to extract that, and then we can jump to that same time period in your system suitability data. So kind of being able to trace back and build confidence in those experimental results. Always looking to make the system more performant as we keep adding new metrics, as people keep adding new data. We need to keep staying on top of that usability aspect. And then on the AutoQC side, the team just in the past month or two released a great new update. It allows you to more easily choose which Skyline version you want to have that it's using to do the analysis, including Skyline Daily. So it's very convenient to kind of set up one configuration to look at one or another to something else. You can import, export configurations. That's great if you're moving maybe from one instrument machine to another. Just improve logging and feedback so you understand what it's doing, if it's getting a problem, to be able to diagnose that and or request support. So kind of call to action. Hopefully you're excited about either doing more rigorous system suitability or automating maybe something that you're already doing in a more manual way right now. So I think choosing your sample, setting up your Skyline document, getting a place in Panorama to start importing that data. You get a free project at panoramaweb.org. That's hosted at University of Washington by the McCoss Lab, like I mentioned. Get AutoQC in there to automate that. Get that out of your daily routine. All you need to do is check your email, see those results. And of course, anyone who's interested in a private server, pharma and biotech, I'm looking at you. We are more than happy to support you. We've got something called the Panorama Partners Program. That's really a collaboration between LabKey, the McCoss Lab, and our corporate partners to get you all these great tools in your own environment, whether that's something we're hosting or something that you're hosting in-house, to get some of those premium features like the custom metrics and the email notifications and so forth. So looks like we've got some more questions, and please keep them coming. I think we've got another 20-25 minutes on our time slot. And let's see, Lindsay, you may have been scanning the list more actively than me in the last minute or two. Anything you want to jump on?
So there were a couple questions that multiple people asked that I thought we could get to first. So these questions center around the idea of if you have multiple instruments and you wanted to display several of your instruments on one dashboard, is there any way to do that?
Yeah, so I think that gets to this slide. So I may have covered that a little bit. This is a way where, if each instrument or each kind of configuration of an instrument, it may be that for different projects, you're using instruments in different ways and you want to do different system suitability accordingly. You would configure separate folders for each of those, and then the dashboard will kind of roll up that full display. So here I've got two, just so the screenshot didn't get too small or unwieldy. But we could easily have 5 or 10 that are all feeding into a display like this. And of course, they can be similar instruments, they could be totally different instruments. There's no requirement that they all be triple quads or any groupings like that.
Yeah, that gets at another question from Pavel, who is asking about if you have one instrument and multiple people are running different types of experiments, so they're switching columns on and off, would a configuration, should that look like a single instrument configuration where everybody shares their QC, or should each person have their own QC folder? I think that gets at that same question. So you could imagine these two examples that Josh is showing here. You can imagine this being the same instrument, but two users. So I've seen it done both ways in the various labs that I've been in. It's nice to get the longitudinal look at a single instrument's performance over time. So I do like if it's switching different types of columns, like actually different packing material and different column lengths, maybe making that each their own QC folders. But if you're using the same general type of column, you're all using C18 and they should be, I don't know, like anywhere between 20 and 30 centimeters. I would probably set that up as just a single AutoQC folder, and then just mark with those annotations when there was a column change and reset my guide set for that new column. So that's how I would navigate that kind of thing, just that I get a longitudinal picture of all the other metrics that are going on, like the pressure on my LC system, and the fragmentation and the peak areas.
Yeah, and then the AutoQC side on that slide. Yeah, if you do decide to split those into separate folders, what we would have is probably two different configurations in AutoQC, looking at two different folders for raw files, and then you configure the instrument, hey, drop column A into column A folder on the file system, B into B, and then AutoQC will route those to the appropriate spot in Panorama that you set up.
Yep. Yeah. So that was another question was asking about, is there a specific format, like a file name format or something that you can specify for AutoQC to automatically pick up those raw files from the folder which contains all the raw files? And yes, absolutely. Like Josh was just saying, you could use a file naming convention and use like those file filters. Or if there's a specific folder structure, directory structure that you use on your instrument, you could also set it up to do that. And I'm like trying to get like advanced in these. So I have set up on some instruments multiple, using a folder structure, running multiple AutoQCs at the same time. So I have 3 different quality control. I have a protein digest, and I have an enrichment document, and then I have my system suitability document. So I have all 3 of those AutoQCs running on the same instrument, just watching different folders, different file structures, pulling those into their respective Skyline files, and then routing that in Panorama to the different dashboards, so that I could monitor both the quality control with my protein digest, my system suitability of my LCMS, and then also get a glance at how my enrichment is going. So yeah, you can absolutely use different file formats, either the file name or the directory, to specify which AutoQC folder should be monitored. Another good question multiple people are asking, Josh, if I use AutoQC for actual QC data, and you're pushing that up to Panorama, is there any meaningful content about the rest of their raw files that are getting published to Panorama Web as well? So sensitive data, but the QC data itself is not there. Like, are these raw files getting pushed up? Is there any other metrics getting pushed up to Panorama besides what's being extracted and shown on the dashboard?
Well, so it will have the full Skyline document. So anything that Skyline's kind of extracted and analyzed would be included. But the full raw file or any other targets that aren't part of your kind of Skyline template document, that won't be captured and pulled up. And I see some questions too about, does that mean the data is publicly accessible? That's totally up to you. So I think most labs probably keep their system suitability private, and maybe they choose to share, support a publication, a data set, and maybe they would do the relevant system suitability checks as part of that data sharing there. But you have complete control if it's private to your lab, or if it's open to the world, or it can be in between too. You can say, hey, I'm working on this data set, Lindsay, I want to give you access to it, but not everyone in the world. So you've got a lot of fine-grained permission controls, and whatever you're comfortable with, and whatever makes sense for that particular project. Can definitely relate.
So question about visualizing two metrics side by side. So is there a way to, for example, see peak intensity and retention time as like two metrics side by side or on top of each other? Is that something you're thinking about?
That is definitely something we're thinking about, and we'd love to either kind of hear more examples of how to pair those, which ones are compelling to look at together, to kind of pre-configure that, or that is something that can be set up. We can do paired metrics, kind of split Y scales in that customization. So that's one of those premium features that I mentioned, that you have access to on Panorama Web. And I think we've got one built-in one, which I think is essentially precursor area versus transition area. So I mentioned the ratio between those as being one of the metrics, but I think we've got a pre-configured option to see those as kind of two separate series on the same plot. So I think that's definitely a nice future step here is, what are good ways to compose these individual metrics together, to again give us a little bit more of a summary view of the highest importance.
Kind of maybe a technical question. Do you need admin rights to change or create a guide set, or can any but user do that?
So it is all permission based. I believe that to create a guide set, you just need to be an editor in that folder. But you could have users who are editors who are allowed to say upload new Skyline documents or delete a Skyline document that got dropped in the wrong place, something like that, versus just readers. So a reader is going to be able to see everything, but not mess with the guide set, not disable a metric, that kind of thing. So I think it's just basically edit access versus read access, not a separate admin. But again, we'd be curious to hear from people. Do we need more levels of granularity? In general, we're trying to have the simplest set that works for people, as opposed to having more knobs to turn than we truly need.
What about ion mobility as a metric? Ben Collins is saying Skyline is storing measured ion mobility values in the precursor results, we think. So could we get ion mobility as a QC metric, like retention time?
We could. So that's something that we've been kind of working closely with the Skyline team, Brian Pratt in particular, on folding ion mobility data into those Chromatogram libraries that I mentioned briefly earlier on. It's not something that I don't think I've heard that request for a metric before, but
Can I jump in?
Good idea.
So the metric that we probably need to add in Skyline is an ion mobility error, just like we have mass errors. So we've discussed that with instrument vendors having, some sort of thing that says, oh, this is the ion mobility error, and then we would track that as a metric. So it's like you're extracting based on a predicted or an expected ion mobility time, and that can drift, or an expected ion mobility value, and that can drift just like your mass calibration can drift. And so yes, there's work to be done there. It's definitely on our radar going forward, but it has to happen in Skyline first, and then it will get propagated to AutoQC.
Great, thanks. And those who didn't recognize the voice, as Brendan McLean, lead developer on Skyline. And then we're also working with the Skyline team. It's not quite scheduled enough to get it on that list of future metrics, but we've had some requests to track kind of peak asymmetry or skewness, or some other kind of peak scoring that I know some of our Panorama partner users are interested in being able to fold in as a metric as well. So definitely lots of good ideas on the list.
Yeah, so we've got a couple questions kind of remaining in the chat here, one of the questions, can I set up different URL than panoramaweb.org, independent from a folder on Panorama?
So it needs to be a Panorama folder. It doesn't need to be one on Panorama Web, though. And I know it could be confusing just in terms of the name. So Panorama Web is the name for the server that the McCoss Lab is hosting at the University of Washington, that people can get a free project on. And if you don't have one, I'll re-encourage you to do that. However, if you've got your own in-house installation of LabKey server, behind your firewall, kind of within your IT team's jurisdiction, you can point to that server instead. And so in that case, basically it's whatever server you go to access Panorama in the web browser, that's what you would put in. Let me go ahead and find this URL here. That's the server that you want to go to. So if you're using that shared server, panoramaweb.org, if you're using your own custom installation, put in myserver.labkey.com, for example. And then the folder within that server, whatever that folder name is, that goes down here. So if you've got follow-up questions, please feel free to reach out or post on the support forum. But basically, if you've got access to any Panorama anywhere, you should be able to do it through AutoQC, whether it's Panorama Web or not.
So still getting some questions in, but I wanted to return to maybe more of a discussion question. So we have mostly been talking about using this in the sense of looking at MS2 chromatograms and analyzing MS2 chromatograms. But I know that there is a lot of people looking at DDA and DDA metrics. So a little bit maybe discussion about why we are pushing for MS2 metrics versus MS1 metrics and PSMs that a DDA run would tell you. For a lot of the work that we're doing, it's quantitative. So knowing the PSMs, the number of PSMs, tends to mostly just give you like an overview of the whole process of LCMS. So I prefer looking at MS2 level statistics, which will kind of divorce like my precursor from my fragment results, and doing these kind of targeted analyses with Skyline gives you a much better look at the chromatography, in my opinion, than a DDA run would give you with a chromatography trace of like an MS1. So using this, you're not going to get metrics like the number of PSMs. You're not going to get the number of peptides and proteins that you detected. You're going to get quantitative metrics about the performance of the instrument that are extracted ion chromatograms. That said, you could set up Skyline to extract precursor MS1 information from a DDA run. That gives you some sense of things like the chromatography of your system. You'll get the MS1 chromatogram, and you would do the same thing. You'd have to pick peptides that are like scream and signal and like very solid stability over time in your HeLa digest or whatever you're doing. Maybe you're spiking in PRTCs into HeLa. I say maybe because I know at least one of you are using a HeLa digest, spiking in a PRTC mix. Maybe you would take those PRTCs and extract the MS1 information out of them. So you could hack this system to work for DDA, but we're really not as interested in MS1 metrics like a DDA metric, a DDA PSM kind of thing. So you can get MS1 metrics. So like you get the tick, it'll tell you MS1, it'll tell you precursor information. But yeah, just wanted to clarify, we're not really going to get like PSM's peptide protein detections from a HeLa digest like a lot of the DDA focused labs would do.
Right. And I think, you know, the other, I think, benefit to this approach, in addition to what you said, Lindsay, is the metrics that we're tracking tend to be a little more kind of actionable, you know, in terms of like, oh, retention time shifted. That's probably a column issue, as opposed to, oh, my IDs dropped by 50%. Okay, that doesn't really tell me where the problem is. Obviously, it is a problem, but in terms of being a little more diagnostic of what the root cause might be.
Yeah, and you could totally, like, in the DDA analysis, you could look at the ppm and the error to get some of these metrics too. This is just a more automated one-stop shop to get those metrics, rather than doing your DDA database search and then pulling those metrics out of your data, or using an Excalibur template to do that manually. This is just an automated way of doing that using free software that already exists. More questions getting going. I see a question for the peptides I used for BSA, so I'm going to try to get you those. So a question about the QC annotation boxes. The date and time setting is always confusing. Future requests for maybe getting a calendar in there.
Yeah. So I think this is the screen where that I didn't show in my screenshots here in the deck, but for setting one of those up, and yeah, you do right now need to know the kind of date time format that the server is expecting, and yeah, I'd love to make that a little more of a calendar control or something like that. I guess it's definitely great to hear from people that they are using those annotations. You know, that's definitely kind of a +1 to prioritize that, because I was always worried that it sounded like a good idea, but that people didn't use it as much in practice. So thanks for that feedback.
I think that's pretty much all the questions. There's a couple questions in here. I see Brendan answering a Skyline question. We got a question that sounds like maybe more of a specific question about this person's needs troubleshooting their AutoQC.
Yeah, I think in general, if folks are getting errors or having things crash or not upload as expected, definitely encourage you to use the Skyline Sport portal, and if you can share a data file or give us log snippets or things like that, and we can help troubleshoot, ask for specific things. But I think we'll probably need to dive in a little more to the specifics to figure out what might be going wrong in that case. I see a separate note on, is it possible to use AutoQC to stop the instrument when the system suitability moves out of bounds? And so right now we haven't done that level of kind of connection. There's the email notification like I talked about. And alternatively, our emails about recently imported immediate. Yeah, so the AutoQC notices that file showing up, and there's a little configuration for how long it should wait for the acquisition to finish. But AutoQC, when that timeout is up, we'll analyze it. These tend to be very small files, small Skyline documents, so 30 seconds or less. And that's imported immediately into Panorama, and the email will go out. So I think that's definitely the closest triggering mechanism we have right now. I'd be interested to learn more about what integration possibilities we might have for different instruments to stop things in their tracks. But we definitely wanted to make sure the emails were meaningful and that we had the right thresholds available, as opposed to having something that shuts down your mass spec when you really don't want it to.
Yeah, I got 2 questions now on using AutoQC for DIA data. That's what I do. So you pick a couple peptides, 10 to 20 peptides that are in your sample, set up Skyline to do the extracted ion chromatograms for those 10 to 20 peptides. do a little method development, make sure that they have good signal, they have good transitions, and they're stable over time. Pick them spanning across the length of your gradient. Or if you're using IRTs spiked in, you can just set up those IRTs. Acquire with a DIA method and analyze your data. So it's set up exactly the same as you would do a PRM or an MRM. You just change the transition settings, transition settings in Skyline to be a DIA workflow. So very, very easy to get it set up for DIA. So I got one last question. Would you consider plotting BPI as a metric? I do not know what BPI is. Maybe we can get that in the chat real quick.
Wondering that as well.
I'm Googling BPI versus tick.
Recall
Base
if you're
peak
still on,
intensity.
and,
So there is a metric for with that base. So that should get you to there. There's also full width half max, I think, is a metric as well.
Yeah.
So you can use those. That should get at that. So that's all the time we have, but we got through all the questions.
all right. Well, awesome. Thanks, Lindsay. This was great. And I know there were questions early on about will we be sharing recordings and slides, and yes, just to reconfirm that. I think we'll get an email out to everyone who registered, which is probably everyone who managed to get into the session, with some of the follow-up links and that data. Thanks for joining us, and yeah, please stay in touch.